Right, today our lesson is on Lewis dot structures and polarity. So pull out your notebook or a piece of paper, write down the title, and then we'll get going for today. Alright, so we're going to be looking at these Lewis dot structures, and we're going to be determining if they have polarity or not, so if they're polar or not. So let's write down a couple things about Lewis dot structures. The first thing that we need to know is that each of the dots on your Lewis dot structure, so these dots right here, each of those dots equal 1 electron. Alright, then you also notice that now in these Lewis dot structures we're starting to see these lines, and these lines are bonds between two elements. And these bonds, in each one of them there are 2 electrons, so the line equals 2 electrons total. Alright, that's just something to help you orient yourself. Now, we also need to remember for this the definition of polar. So polar is when there's unequal sharing of electrons. It also is going to leave a charged end. So we're going to be talking about that. We're going to have our molecule have a charged end that's negative and a charged end that's positive. If we don't have that, then it's not going to be polar. So that's kind of important to know about. So for each of these elements, we're going to go through. We're going to decide if they're sharing the electrons in the bond equally. And then we're going to decide if it's going to be partial negative, partial positive, and if it's going to be polar or non-polar, okay? So here in this bond, this O and H, they're going to be sharing electrons in this bond right here. Now you have to think to yourself, are they going to share it equally? So if an element wants electrons more, it's going to pull the electrons closer to itself. Now you know in your periodic table, O is closer to having 8 valence electrons, so it's going to actually pull these electrons in closer to itself in both of these bonds. When it does that, when it's pulling those electrons closer to itself, it's going to be a little bit negative by the oxygen. Remember that sign there means partial negative. These hydrogens, on the other hand, are going to have less electrons close to them, so they're going to be partial positive on both of them. So you can start seeing that in these bonds, there's going to be some polarity because we have a negative end and then a positive end down here. So this oxygen up at the top here is going to be kind of a negative, and then it's going to get to be positive on these ends. So kind of like the top yellow part is a more negative part and the green part is a more positive part of your atom. So this is actually going to be a polar molecule. Now let's move over to our other example. If you need to pause the video to write down these examples, that's totally fine. I would do that. But let's jump over this other example. So we have the O, and it has these 2 bonds. So it actually has a double bond in the middle. That's what 2 of the lines mean. Now think to yourself, do either of these oxygens want an electron more than the other one? And your answer would be no. They're both the same element. They want electrons the same. So because of that, this molecule is going to be non-polar. We don't have to write any of the partial positive, partial negative, anything like that, because they're going to share electrons equally. Alright, let's jump down to this one. The C with 4 H's around it. So something that you have to remember is that C and H, they want electrons the same. So since our C and H want electrons the same, they're actually going to be sharing the electrons in these bonds. All these bonds are going to share the electrons equally. So since they're all sharing it equally, this bond is also going to be non-polar. Alright, let's jump over to our next example. So now we're looking at an N with 3 H's around it. In these bonds, the N is going to want electrons more. Alright, so whenever you come to a molecule, think, do any of the elements want electrons more? So since we know that N is going to want the electrons more in these bonds, it's going to hold it a little bit closer to itself than the H. Our N is going to be partially negative, and our H's are going to be partially positive. So if we get our highlighting again, and we use our green to show where the positives, so we kind of have positives on this side of our molecule, and then we use our yellow to show where our negatives are. This part of the molecule is negative. You'll see that we have a positive end and a negative end. And so this is going to be polar. Now this last example is the trickiest example, so keep watching. Okay, so if we look down here, we have C sharing with 4 different Cl's. Now, out of those, we know that Cl wants electrons more than the C, right? It's closer to getting 8 valence electrons. So those electrons are actually going to be closer to our Cl's in these bonds. So that's going to leave us with this partial negative out on each of the Cl's and a partial positive in the middle on our C. So if we color our molecule with the partial negatives on the outside and our partial positive in the middle, you'll notice that this one actually doesn't have a charged end. That's, one side is positive, one side is negative. The negatives are surrounding the positives. So this is actually going to be a non-polar molecule because of that. Because the negatives surround that positive, so there's not one end that's negative and one end that's positive. Alright, so for your homework, you're pretty much going through different Lewis dot structures. You're going to be writing these charges on them, the partial negatives, partial positives, and you're going to be saying if they're polar or not polar. Your homework shouldn't be too long, so hopefully you can get it done pretty quick. I'm going to try to do another video sometime in the next couple days of me doing a couple homework problems to hopefully help you. But always reach out and email me if you have any questions while you're working on it. Good luck!